Hello everybody, welcome to Transy Learning Physics videos. Today we'll be discussing about practice problems related to resistance in series and parallel. So let's see what all questions we'll be covering in this video. The first question. A letter A consists of a uniform wire of resistance of 1 ohm per centimeter. As you can see here, the alphabet A. The sides of the letter are each 20 centimeter long and cross piece in the middle is 10 centimeter long. So here these wires are 20 centimeter long and this one is 10 centimeter long with the apex angle is 60°. Find the resistance of the letter between two ends of the legs. So when we are talking about the two ends of the leg, we need to find the resistance across CE. So this is what we need to find. So first of all, we have to take into consideration the Kirchhoff laws and that too the junction of the current rule, which states that the total current entering the junction is equal to the total current leaving the junction. So as we have to find the resistance across RE, let me consider the current I entering the circuit from point C, and then the same current I should leave the circuit through E point. So as you can see here that the current I is flowing through 10 ohm resistor and it reaches the point B. Point B is a junction. The junction is a point where the current divides. So I'm dividing the current I into I1 and I2. So here I is equals to I1 plus I2. So now this I1 current flows through 10 ohm resistor. It reaches the point A and the same current I1 flows through this 10 ohm resistor and it reaches the point D. So at this point we have current I1. This point D is also a junction because here the current I2 which will flow through 10 ohm resistor is also reaching. So at this point D we have I1 plus I2, and as I1 plus I2 is equals to I, so that means I current is flowing through the point A, which justifies their junction rule. Now we have divided and segregated the current in an appropriate manner. So we will be taking into consideration the series and the parallel combination basis. Then when the same current flows through the resistors, those resistors are in series and we need to just add them. But when the current divides, then those resistors are in parallel combination with each other. Then we need to take the sum of the reciprocals. So keeping in mind the series and the parallel combination, we will find the resistance across CE. So first of all, we will consider this part of the alphabet A. In this case, the current I flows through this 10 ohm resistor and the same current I flows through this 10 ohm resistor. So that means these two are in series combination with each other. So we will first of all find the equivalent resistance across this end and let it be RS1. This will be equal to the sum of resistance across AB and across AD, because when the current is in series combination, then the resistors get added. So this will be equal to 20 ohm. So now the equivalent resistance of this part will be 20 ohm. Now let's see how the circuit will look. Now the circuit will look like this. This is the equivalent resistance that we have found out through the series combination. Now as you can see here, this equivalent resistance RS1 and the resistor across BD are in parallel combination with each other because here the current is getting divided and we will take the sum of the reciprocals. So this will be equal to RP1, that is the resistance across the parallel combination, and this will be equals to reciprocal of the RS1 that we have calculated and resistance across BD. On solving, we will get this as 3 upon 20, and on taking the reciprocal we will get this 20 upon 3 ohm. So this equivalent resistance of solving this parallel combination will come out to be 20 upon 3 ohm. Now let's see how the circuit will look. The circuit will look like this. Now all the junctions are gone. Now if the current I enters from C, then it will travel to 10 ohm and it will reach the point B. There is no junction, so the current will not divide. The same current I will flow through the 20 by 3 ohm resistor and it will reach the point D, and the same current I will flow through 10 ohm resistor and it will leave the circuit from E. So as the same current are flowing through the 10 ohm and 20 by 3 ohm and 10 ohm resistors, so these three will be in series combination with each other and we will just add them. So the resistance across CE will be equal to resistance across CB plus resistance across BD plus resistance across DA. On solving this, we will get the value as 80 by 3, and if we calculate it will come out to be 26.67 ohm. So this is the resistance across CE. Part 1 ends here. Thank you for second part of this video, and for more videos you can visit our website transealearning.com. Have a great day.